today's video, I'm going to show you guys how you can code anything you want in Roblox Studio. And it's pretty simple, but it does require that you sit down for this video and you take the time to learn the new concepts that come. This is a very simple approach, but you can also make this really advanced quickly. So basically in this video, I'm going to show you that we can make a bank system. So it's going to be a really single bank system. Basically, we're going to be making the back end of the bank system, and then we're going to be quickly showcasing how you can use it in your own game. So quickly, to get started, make in replicated storage, you can make folders. You can do this on your own, just change the variable names around. In my case, I'm just going to make them directly, but I do recommend that you guys do folders and that you research, how to organize your games. Because in the long end of making games, it's very important that you have very good organization or it's going to get too messy. So to get started, go into replicated storage and make a module script. Now I'm going to call this one shared types. You can call it whatever you want. And basically for this, I'm going to quickly have a script and just run the game. I want to just zoom in a bit on the output. There we go. So basically for this system, we're going to have a shared types. We're going to have a script. And inside the script, we're going to have another remote event or a module script, sorry. And we'll just call this one bank class. And we'll also have another module script called Assert. So this is basically our setup, and with this right here you can get the idea of how we're doing this, how I'm structuring making a new class for a game. If you're confused with module scripts, you haven't worked with it before, you don't know what I mean by classes and etc., I do recommend that you guys search up OOP, which stands for Object-Oriented Programming, which is another method of doing your program. It's another way to think about programming. There's a bunch of materials on the dev forum that you guys can go ahead and grab, or you can just follow along in this video and I'll try to explain it as well as I can. So go ahead and open these scripts up, and I'm gonna start inside of my shared types module. So basically we can just match the name real quickly, and this is just for organization matters. So we'll just match this with the actual name of the module script. So here we're gonna make our first type. So I'm gonna call this one the bank implementation. And basically what we're doing here is we're exporting a type. A type in Roblox Studio is basically if you're saying, function, if you're saying local function new, and for this function, for example, you want to pass in an argument, like a name, and the name has to be a string. All of these are types that it can be, but sometimes you don't have the specific type that you want to use. So therefore we're making our own type. So like string is a type, or number, boolean, nil, any of those things are a type. We're basically making our own type. And then we're exporting the type so we can use it in other scripts. So this script will basically serve as like the data holder, you could say, for all your types, and you can just add more types onto this. For this example, we're only going to be needing to make one, which is the bank implementation type, but you can make as many as you want for as many different systems as you want. So we're going to start by indexing the bank implementation with itself. Just type __ index. And again, more info on this can be found if you search up object-oriented programming. It's a way of inheriting and stuff like that. Now we're gonna call our methods for this type. So we're gonna have a new method, which is basically gonna be for when you're making a bank, you wanna make a new bank. So we're gonna use the colons, and then we're gonna use the parameters and or the parentheses here. And the parentheses are basically indicating that new is going to be a function. If I just did, for example, name, location, etc., then it wouldn't know it's a function. So using the parentheses like this, we're indicating that the method new is going to be a function, like bank.new, for example. So we're going to make it a name, and we're going to specify that the name of the bank has to be a string. If you're confused, a string is a piece of text like this. That is a string right there. So we want to be able to set the name to, a name, like a string, not a number, for example. You could have that as well, but in this case, we're going to do string. We're also going to make a location, which is just, to further show that you can add more stuff onto this. you don't need it, but I'm gonna have it for mine. And we're gonna make a budget, which is a number. And basically what we can do now that we have the name, the location, and the budget is we can tell the script what we want to get out of this, like what we want the function new to spit back out. And you can do that by making an arrow and then just type bank, because we basically want the new to, you know, make us a bank. And then we can make some other methods, and this is just, you know, for showcase. You don't need to have other methods. You could just have your bank, and that's fine. We're gonna make a method that's called support. So basically you can support the bank. Actually, we're gonna take that back. We're just gonna have a withdraw function, and then we're gonna have a deposit function as well. So basically with the withdraw function, we're gonna do the same as before, and we're gonna use self bank, because now we're basically, after we declare that we have the bank, we can just use self as like the keyword for, you know, the bank itself, and just, you know, for type checking purposes, we're making sure that that is the bank. And we can have the amount, which would then be a number. And for this, we aren't gonna really use anything. Like, we're just gonna tell the bank class that we want to withdraw money. We don't need it to necessarily return us a new bank, for example, because we're already using the self bank here, which is the already existing bank. If you were to, for example, want to see the updated changes, you wouldn't need to even call bank here, because you can just call bank dot if you had a bank dot money, for example, and then, you know, you can see, or bank dot new, and then you can see the budget, because we'll just have the withdraw take from the budget, and we'll have a deposit, which we'll make now, give to the budget. So if we have a deposit method as well, same thing as before, self, which is bank, and we can just say, for some purposes, we can just say credit, which is a number. And again, for this, we are not wanting to return anything. So we're basically just returning parentheses, which is the same as saying we're basically returning nil, or we're returning nothing back. So basically what's happening here is we're making a type called bank implementation, and it's indexing it in itself. And we're making a new bank here where we are getting a bank from these parameters. And then we have two options to add or remove money from the bank. So think of this as like a bank, and you have 100 users, and the 100 users are actively taking from withdrawing and depositing from the bank. It's not exactly how it works in real life, but you get the idea. We have like a massive pool of money, and when users take money, the pool gets smaller, and when they add their own money to the bank, the pool gets larger. That's not actually how money in banks work in real life, but that doesn't really matter for now. So that basically calls it all we need for this shared types. It's very small, but we've managed to make our own type, our own bank implementation. So what we can do now is we can move on to the biggest part of this, which is making the actual bank class, because now we have the implementation of making it, but now we have to make the actual class. So we can start by doing this, by removing these lines, and then type bank, because now we want to make, we have the bank implementation, but we want to make the actual bank. And this is what we're referencing to in here. And that's going to be type of set metatable. And then we're going to make a metatable, which is, it basically handles all the data that we're using for this bank. So all the methods that we're making, and all of this, the index and the set metatable all goes into great detail if you find any OOP guides on the internet, or in the dev forum. If you're a video learner, then you know, that's probably why you're here watching videos. Then you can find YouTube videos that explain it into great detail. But for now, all you need to know is that set metatable basically makes this table here control the data. And then we're going to clarify that it's going to be needing a name, which is a string, a location, which is a string as well, and we call it budget, which is a number. And basically, we're just gonna talk to the, we'll say shared types, the bank. Actually, wait, we'll wait with this. We'll just have this for now. because what we need to do is we need to clarify our shared types module. So go ahead and get replicated storage real quick using get service, and then you can go ahead and get the shared types using the require, which is basically the method of getting module scripts. And we can use the shared types, and we'll also, while we're at it, we'll get the assert, which I'll get into later, but we'll get the assert module as well. And now we have both these modules. So now we can say shared types dot bank, and you can see it autofills here. So just press enter. So basically what this line does is it makes the type of a bank, which holds all the data using this meta table. So basically looks through with these, it basically forces or casts the actions or this into the bank. So it makes sure that our bank aligns with our bank implementation. Yeah, I mean, that's basically all you need to know. And we again have the types here, or the parameters, if you will. So now we can go ahead and make the actual bank thingy. So just say bank shared table dot bank implementation is equals to an empty table, because basically we're just setting the bank to be an empty table for now. And then we can get the again shared not shared table. I think that's why it didn't show up automatically. It's because we did shared table. We got shared types, the bank implementation, and then once again bank implementation, and there we go. So now with this, we've made the actual bank instance, if you will, the bank variable. We can just go ahead and index the bank with itself. And now we can get to making the actual function. So if this was confusing, don't worry. This is knowledge if you're new to Roblox Studio, this is knowledge you definitely don't need to understand everything. But just follow, and I hope you understand some of it. And at the end of this video, it's all gonna make more sense when we try putting it into actual practice, instead of all this deep coding stuff. But let's get into some functions, because that's a bit easier. So we're gonna have a bank.start function, and this is not something you need. Most systems you'll have a module loader, and a module loader will probably require you to have at least the modules you want it to have. You're gonna have a start function, which basically makes sure that the module script loads properly and it runs before we try doing any of the other functions. So just to show that we're actually doing this, we're gonna just have a print. Let me see, we'll make something cool for this. We'll just do like this, dot script.name. So we'll just reference to the bank class, and then we'll use the started execution, and then we'll close it off again here. So this is again nothing you need, but it's nice to have, and it's definitely something I think you guys should consider, is getting a module loader and using the module loader for scripts, because it's just simply better to have it, and it's also more organized. So we can also have a function, and now we're actually getting into the functions for the actual bank, not just for blah blah blah. So this will be the bank.new, which is what I talked about before. It's the thing we have right here, and we can just go in and look here, and we can see what we want to have as the parameters, and we can actually just copy this and just paste it in here. And just like this, we can press enter as well. We've now declared that bank.new takes in a name, location, and a budget. You don't need to have this string, and number, because that's essentially what we're doing here. But for the purposes of visualizing for you as the viewer, then I'm gonna have this here, because when we then call the function, we can see that it takes in a string and location and budget, the numbers and whatnot. So basically, now we gotta stop with this bank class, and we gotta make the assert module, because we need the assert module for the next thing that comes up in the video. The assert module is pretty simple. Just make sure you call it assert. Don't call it with the small assert, because that'll run the actual event that we want the module to be used for. So make sure it's capitalized A. And we'll have a function assert call assert, which is going to be, we'll say value and value type. And then we run the actual assert, which is the type of the value. You can use the value type, comma value, dot, and then we gotta format it. So we'll say must be a dot value type. And this basically just we will call this when we have the parameters here. When we have the name, the location, and the budget, we call this in here, and basically what it does is we send it through to the script. It looks through all of the values, so all the parameters, and it says, you know, if the name, are you really a string? And if it is a string, then all good, no worries. And if it's not a string, then it'll call an error indicating and showing us that what we passed through is wrong. And it's easy to read in the output, and we can easily, you know, fix our errors with it. So this one will call a single assert, but what if you have multiple asserts? Well, then we'll need a function assert call multiple asserts, I guess you could say. And we'll have assertions as the parameter. And basically we'll say for each assertion we'll use ipairs assertion do. So for each assertion that we're passing, did I misspell that one? Oh, that's because I'm messing it up. It's because there we go. Has to be like that. So put the s where we want to look for, and then make sure this is without the s, so that we can reference each single assertion. We can say local value, comma value type, because we're basically, yeah, it'll make sense. Equals to assertion. Oh my god, I'm so bad at spelling. And then we'll use the first index, and we'll use the second index. And with this, we're actually going to reference back to our call assert space just for calling it multiple times. So we'll just call self call assert value, comma value type, and we can use self because we're using the colons, which is basically self. You could, if you're using a dot, you can just say local self like this as well, but since we're using colon, we just get this self. You have to do some other workarounds and stuff, but this basically just calls this function up here, but with multiple, so it's like a for loop that calls all the assertions. But this is all you need for the assert type. So now back in the bank class, what we need to do is, for this first one, we have 3 parameters that we need to run through and make sure are actually valid. So it's really simple. We got the assert table, the module, sorry. So we'll just say assert, and then you can see we get the function we just made. And since we have multiple, we have more than one, we want to call multiple asserts, and just go ahead and make a table. You're going to need to make 3 tables for this. So put a dot on each one. Make sure it ends with closing the first table and the first parentheses. So basically in the first table, we'll just do name, which should be a string, and name I'm referencing to the bank name. The next one is the location, and you can see the autofills for us as well, which is nice because we made a type so it knows what it is. So you can see the budget, and it even says already, you can see budget, it knows it's supposed to be a number. But we're just double checking here. And again, you don't really need to do this. This is just for double checking and for making sure your code is even more robust. So then we can get the self. Since we're using the dot, we don't actually get the self. So we'll just basically make a self table, and we'll set the name to be the name, and we'll set the location to be the location, and the budget to be the budget. And then we'll of course close it off, and we'll return by setting a meta table with self and the bank. So we're basically setting a meta table with this data and the bank. So this is all for your bank that new. This is the biggest function that we have. And now we'll just do the 2 small methods that we had from before. So that was the withdraw and the deposit. So we'll say function bank will have a withdraw method, which took in an amount, which is a number. It's not giving us anything in return. So this is the same as saying we're returning nothing, really. And basically up here, we are returning bank, the type of bank right here. So basically with this, we now have the bank withdraw function, and we just need to code it, but we'll also make the deposit, if I can spell right. And that was the credit. And again, we're not expecting any, we don't want anything passed back after using this. We're not returning anything. So with this, we gotta call each assert, and then we gotta add to the budget. So you can just say self.budget plus equals to the amount. And the same logic goes for down here. Just change credit. And basically now we are currently, what we're doing is we're adding money with withdraw, which you shouldn't. So make sure it's actually minus equals up here, because basically what happens is when someone calls this and they call an amount, we basically subtract. This is like the self-start budget, is like the pool of the bank, like the money pool. It will basically subtract that from the amount of money we want to take out of the bank as the user. And down here, it's the opposite. We're just adding money to the bank. But we also got to make sure that we're asserting it and we're getting the types correctly. So use a call assert, and then we'll just use call assert because we're only handling with a single one. And then you can just do the name. So my name is amount, and we want an amount to be a number. Copy this and paste it down here, and then just change it to credit. And there you go. And then lastly, we'll return the bank. So basically what we're doing here is we have all the methods that we initially made in the shared types. So now we have the 3 module scripts scripted, and now we can go ahead and go to the server script, which I'll rename server real quick. And in this, we can go ahead and get the bank class real quick, requiring the script.bank class, which is the module we just worked in. And we can initialize bank class by saying bank class.start. If you have a module loader, you don't need to worry about this. You would automatically have it initialize just by having the function start. That's how module loaders work. But in this case, since we don't have a module loader, worked into the system, we'll just initialize it ourselves. And then we'll make our bank. So we'll call it new bank. And then we'll use the .new function. And as you can see, we're expecting a name. So we'll call this the Robloxian bank, I guess. And we'll say that we want it on like Roblox Avenue. There we go. We can put like a number. We'll say Roblox Avenue 110. There we go. I don't know if that's how it works in the US, but we'll do that for now. And then we'll just set a base budget. We'll say $1 million. So I'm pretty sure that's 100,000, 10,000, 100,000, $1 million. Yep, there we go. So just for clarifying it, we're just gonna comment. There we go. So we're basically setting a start pool of $1 million. We can go ahead and print new bank. And basically, when we go ahead and run this code, what we'll see is that first off, the bank class started execution. And this happened because inside of here, we called the bank class.start, which ran this function, which basically just tells us that you're good to go. We started running the thingy. And then down here, we have the table, which we can expand. And this is the new bank that we created. So basically, there we go. We're getting a budget of $1 million for this bank. And it's telling us the location is Roblox Avenue 110, which we set here. And the name is the Robloxian bank. Now, what we can do is we can use the methods we made before. So we can say, for example, new bank. And we can say we want to add like $100,000. So again, just for clarification, we're adding $100,000, and then we'll go ahead and print it again. And then after this, we'll go ahead and actually withdraw like $250,000 or 250,000, whatever currency you're working with, and we'll print it once again. And this is just for showing you guys, how that works. So when we have this, as we can see right here, so we made the bank, and this is our initial bank data, as we have $1 million currency, whatever dollars working in this bank. That's like our base, budget. And then we deposited 100,000. So as you can see, we now have $1 million and 100,000 currency. And then we took out, I think I accidentally took out, oh yeah, I put the dot here, which I'm not supposed to. There we go. So if you run it one more time, you can see we took out $250,000. So now we're left for currency. So now we're left with 850,000. So that's practically how the bank then works. What we can also do is we can change, for example, the name of the bank. We can change the base pool of the bank. So how you want to change anything in the bank is you simply just call new bank and then what you want to change. So e.g. the name, and you can call this, I'll call this my bank. And now if you go ahead and run it again, you see up here, it's still going to be Robloxian bank because that's initially what we're telling it to. But down here, we're we're not printing the changes. So go ahead and print it again. And you see on these three right here, it's going to be Robloxian bank. That's the name. And then on the last one, it's going to update to my bank because we're telling it to update the name. And the same goes for the location and the budget. You can also add new methods inside of here. Just simply go ahead and add your method. And then once you've done that, then you can go back in here and you can add your function for that method. And then you can just directly call that function in here using the new bank. You can also make more banks. You can just call bank class.new as many times as you want. And as long as these are right, then it's going to work. So for example, to show you guys that our assert thingy worked, we can go ahead and put the $1 million into a string. And basically we're expecting a number, but now we're giving it a string. So let's see how it's going to respond. So as you can see, it actually starts the execution because we're telling it to start first. And then it's basically telling us afterwards, it's calling an error from relocated storage at assert, line 4. It's saying $1 million must be a number. If we go and open it up, we can see that we're getting the function assert, call assert. So it's basically giving us an error telling us that the $1 million needs to be a number because we're telling it inside of the bank class, right here, we're saying that budget should be a number. So if we go ahead and change this to string, then as you can see, it works perfectly fine because now we're telling the system that it needs to be a string and not a number. But of course, it needs to be a number because we're working with money. So we'll have it as a number right there, and then we'll go back in here and we'll remove this. Okay, so another way we can use this bank system is, let's say we open up the toolbox and we have a bank. Let's see if we can find a good bank. We don't have to be the biggest one. We can just use this bank. So basically what we could have is we could have a billboard GUI. So inside of, actually this is a, yeah, we'll do this. So basically we'll make a part, and then inside of this part we'll make a billboard GUI. And you don't have to do this. This is just to show, you know, how this would work. And then we'll place it like 5 studs above, maybe 10 studs above the base part. And inside here we'll have the text label. And then we can mess a bit with the text label. We can make it transparent. We can make sure that the text is scaled right here. As you can see, it should stay the size that it needs to be. We can make it, if we go in font, make it some thick text, and we can change it to like Fredoka 1. Change the text color to like a the yellowish, like a yellowish color like this. Maybe, yeah, maybe something like this would actually be fine. So we have a yellowish color to, you know, show our bank. Maybe we can have a UI stroke on this as well. We can make it like too thick, and we could just change the text of this to bank name. And basically now, oh, we need to make it a bit bigger. I think if we make the size of, I can't remember if it's the size of the, okay, so yeah, so it's just, we'll make this like 500 by 100. I think that's fine. And then we'll make the size 1,0,1,0 to basically fill out the entire space of the billboard GUI. And we'll basically call this the bank core. And this we'll call, we'll call it billboard GUI. We'll call it bank GUI. And this we'll call the bank name. And this will go ahead and place directly inside of the bank. I hope the bank doesn't, I hope it's anchored and doesn't fall apart. So we can go ahead and place it right here. Go ahead and, you know, see if we can center it a bit and then get it a bit up. And actually, I think I might just have it go even higher. So I'll have the studs offset be like 20, 25, 35. I think 30 would be good. So basically, you get the point. What we want to do here, we want to update the name of this text label to be the bank name. So for this, we'll make a remote event and we'll call this update bank name, and we'll make a client script. So call it client, and then get replicated storage, get service replicated storage, get the update bank name, replicated storage. We'll use wait for child, update bank name, and go ahead and copy this into here, and we'll say update bank name fire. Actually, we'll use the when the player joins, so we'll get the player service. Yeah, game get service. Oops, players. So basically, we'll have it so when the player added connect function player. So when a player connects to the game, then we'll basically start by we'll do this. There we go. So when a player joins the game, we'll start it, and then we'll make our bank. And then if new bank, then we'll make sure our bank is actually created. And if it is created, then we'll say update bank name fire client. We could also just use fire all clients, but in this case we're going to use just fire client. I mean, you could use fire all clients and you won't need to get the player, but we'll use fire client for this example. And then we'll call the player, and we'll send in the new bank dot name. There we go. So basically we're sending a remote event to, you've probably seen this before, but we're sending a remote event to the player when they join the game. So that's going to be every single player, and we're giving him the new bank dot name. So basically in here we can say local function update update bank name. A bit weird of a function name, I know, but we'll get a name, and we'll basically say that update bank name dot that's because we matched it. Update name. I'm so bad at naming stuff, that's crazy. On client event connect function, or just connect update name. There we go. So once we pass it, we'll go in here, we get the player, and we get the name. Yeah, so basically can't remember if you have to put player first. You might have to. Let's try quickly and print the player come with the name, and we'll see if we need to put it. Let's go ahead and add Robloxian bank comma nil. So yeah, so you don't need to put the player. That's my bad. So now if we print the name, we can see we get the Robloxian bank. So that's perfect. So now we just basically have to get we can say local bank to workspace dot bank. Actually, we'll say workspace with a child bank. We'll make sure that bank actually is loaded in. We'll say the bank core, and what we'll do is we'll set this inside of the bank, and then we'll set the bank's primary part to be the bank core. We'll make sure bank core is anchored and it keeps existing, and we'll say bank core equals to bank dot primary part, and we'll say local bank name equals to bank core dot bank, what do we call it? We called it bank GUI dot bank name. We're saying bank a lot, but you guys get the point. We'll say bank label, just for the sake of doing this. We'll say bank label dot text equals to name. And when we go ahead and play this, we get an error. Let's see what the error is. So attempted to index nil with bank GUI. So let's go ahead and open the bank quickly and let's see what seems to be the issue. So bank GUI, we are setting it to be the primary part. You know what we'll actually do? We'll just go ahead, we'll take it out from the bank, and we'll just say bank core equals to, we'll get this, and we'll say workspace, wait for child, bank core, local bank GUI, bank core, wait for child, bank GUI, there we go. And then we'll get the bank label that way. And as you can see, it now updates, and it says the name of the bank above the actual bank, which is kind of sick. It says Robloxian bank up here. So this is one way of using this bank system. We could also have a proximity part. Oh, we can go inside the bank. Okay, that's cool. we could have something in here. For example, we got a proximity problem that's just like withdraw, which opens a UI. You can ask the player how much do you want to withdraw, and if that's in there, you could have a for each person in the game, you could have like a purse or like a balance for each person in the bank. And then if they have enough money, then you could subtract that money from the bank.budget. But you guys get the point of how to structure this. Again, I would recommend you make folders. So for example, you could call this util, and you could paste your things in here. You can make another one called communication, and put the remote event in there, and then this will be fine in itself, just having all the classes. What you could do is you could add a folder and then call it services, because you typically have services, and then you could have one called classes, and then you could put your services in there, classes in there, and then you could have a module loader. I'm just showing you guys how I typically structure my things. And then you could have a components and modules, we'll just say. So if you look, this is typically how I structure my game. We could also just have a folder in workspace called game, and then you can put your bank and your bank core in that folder in workspace as well. You could have a folder called bank inside of the game folder. So honestly, I mean, this doesn't really, you'd have to change around how we just wrote the system for this to, take place and work. But it's just a general way for you to organize your game, and I recommend you doing this. But I hope you guys get the point of this idea, and that you can code anything in Roblox Studio if you just sit down, you plan how you want to do it. And this is one way of going around doing it with object-oriented programming. And at the end of the day, this is not rocket science. I mean, read through some documentation, some of the methods that I use in the script, like maybe the type interests you, export type, for example, underscore index, like methods, and just figure out really what it does, understand it. Because once you get to the point where you're like, okay, this makes sense, and you have an idea of how to move forward and make new stuff in Roblox Studio, with a mindset like that, you can make anything you want. You don't have to rely on YouTube tutorials at all. So I hope you guys enjoyed the video, and like, subscribe, and I'll see you guys in the next video.